Hello all. So in this video, we are going to solve the problem of maximum average subarray, which is under under the concept of sliding window. Now, what is sliding window? We are not going to cover that, but we are going to solve the problem maximum average subarray. I have already opened this. So what the question is? The question is you are given an integer array called nums consisting of n elements and an integer key. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than 10 raised to minus 5 will be accepted. Example, this is our input nums array. The value for k is 4. Since we want to return a contiguous subarray whose length is equal to 4, we will start with 0 and consider the first 4 elements. The average of first 4 elements comes out to be 13. 13 minus is the average of the first 4 elements is 0. Now the average of the next 4 elements starting from index 1 is equal to 12.75. And once we move to index 2, from here, if we take the average of the next 4 elements, that comes out to be minus 5 minus 6 is minus 5 minus 6 is minus 11 plus 50. So minus 11 plus 50, 39, 39 plus 3, 42. Divide 42 by 4, you get 14. 42 by 4 is 14, right? So maximum average is 12 minus 5 plus 50 by 4. 51 by 4 is 12.75. But minus 5 minus 6, 53. 50 plus 3 is 53. 53 minus 11 is 42, right? But then in this case, that should have been the maximum average. Okay, let us go to our AI tutor. So here we have our project. Click on projects. From here, this is our Socratic interviewer coding problems. And I will paste the problem statement here. After pasting the problem statement, we'll talk about the approach that I'm going to follow. Approach. This is clearly a sliding window problem where k is equal to 4 implies it's a fixed sliding window problem. We will start left equal to 0 and right equal to k, and for each iteration we will calculate the average and store that inside a variable called max. Then for the next iteration, left will be incremented by 1 and so as right will be incremented by 1. The distance between left minus right must always be equal to 4. Must always be equal to 4 if the distance is less than 4, then we stop citing invalid window or specifying we have reached the end of the array. Am I missing anything? No. So let's enter this. Nice. You have got the right instinct with sliding window. Before we touch code, let me probe your understanding a bit. You mentioned you will calculate the average at each window and track the max. That's correct directionally, but here's my first question. If you are sliding the window and recalculating the average each time, what's actually changing between one window and the next? And can you exploit that to avoid redundant work? If you are sliding the window and recalculating the average each time, what's actually changing between one window and the next? What's actually changing? The element pointed by left is dropped and the element pointed by right plus 1 is added into the sliding window. This is what is happening. So instead of recalculating the average for all elements, what we can do is store the sum in a variable, and as the window moves from that sum, subtract the element pointed by left and then add the element pointed by right plus 1. From that sum, subtract the element pointed by left and then add the element pointed by right plus 1. Then we divide the new sum by k, and if that average is greater than the previous average, then we assign max average equal to the current average. So you have identified the core optimization, maintain a running sum and do a subtract add instead of a full recalculation each step. Now before we code, one more thing to nail down. How do you initialize the sum for the very first window? Walk me through what that looks like with the example. How do you initialize the sum for the very first window? The sum for the very first window will be calculated by using a for loop, that is for I equal to 0 to I less than k. We will add all the elements and this will give us the first sum. So in the above case, we will start at 1 and keep on adding until -6. That would be our first sum. So your initial sum covers indices 0 through k minus 1, which is exactly right. Now here's the next question. After you initialize that first window sum and set it as your starting max sum, how do you structure the sliding part specifically? What are the bounds of your loop? Where does it start and where does it end? After you initialize the first window sum and set it as your starting max sum, how do you structure the sliding part? Specifically, what are the bounds of your loop? Where does it start and where does it end? So the bounds of the loop will be the bounds of the loop will be start equal to left plus 1 and end what are the bounds of your loop? Where does it start and where does it end? We'll start from left plus 1. Start will be left plus 1 and left will be left plus 1 and right will be right plus 1 and left must be less than right and right must be less than num start length minus 1. Close, but I want to stress test that boundary condition. Try this mentally with a small example. Nums is equal to 1, 2, 3, 4, k equal to 2. Your initial window covers indices 0 and 1. After the first slide, you want to cover indices 1 and 2. Okay, after the second slide, indices 2 and 3. With your condition right less than nums dot length minus 1, does that last window indices 2 and 3 ever get processed? Okay. Your initial window covers indices 0 and 1. After the first slide, you want to cover indices 1 and 2. Yes. After the second slide, indices 2 and 3. Correct. With your condition right less than nums dot length. So, initial sum is equal to nums of 0 plus nums of 1, which is equal to 1 plus 2, which is equal to 3. Then we say for say left, then we say left equal to left plus 1 and right equal to right plus 1. Or we will call this window start equal to left plus 1 and window end equal to right minus right plus 1 and right is less than nums dot length minus 1. So initially window start will be left is equal to 0 and right is equal to 3. Let me put that. Initially the left is equal to 0 and right is equal to nums dot length minus no, right will not be nums dot length minus 1. Right will be the value of k. Right equal to k. So right will start from k. Now when right starts from k, so we say the next we want to calculate the window 0 and 1 covered by indices. So here window start equal to 1 and window end equal to right plus 1. So right is already 2. Right is already 2. However, since we are dealing with array indices, it should be k minus 1. So window end will be equal to k minus 1 is 1. Since k is 2, so 2 minus 1 equals 1. So k is initially 1. So window end will be 1 plus 1, 2, which is correct. So next we get maxSum is equal to nums of 1 plus nums of 2. which is equal to nums of 1 is 2 plus nums of 2 is 3, which is equal to 5. Then we compare the current sum. Since max sum is equal to 5 and the earlier sum was 3. So now max sum, this is our current maximum. This is our current max sum. Okay. And here we will also check right is less than nums.length minus 1, which is true, or I think this will not be the terminating condition. The terminating condition must be such that right minus left should always be equal to k. Right minus left should always be equal to k. The terminating condition must be right minus left should be always equal to k, and right minus left should be less than nums.length minus 1. But I think you're overcomplicating the boundary check. Let me simplify the version. You don't actually need to track both left and right explicitly. Since the window size is always fixed at key, if you know where the window starts, you always know where it ends. So let's think about it this way. If your loop variable is just I, representing the start of the current window, what value does I start at? And what is the last valid value of I before the window goes out of bounds? What value does I start at, and what is the last valid value of I before the window goes out of box? I start at 0, last valid value is equal to 3, after which the window goes out of box. But be precise, you said the last valid I is 3, but that's specific to the example. How do you express that last valid starting index in terms of what start and change so it works for any? Okay. How do you express that last valid starting index in terms of nums.length and key? So nums.length is 4, so it works for any input. You said the last valid I is 3, but that's specific to the example. Okay, if k is 5, it say we had 10 elements. So what we did the last valid value for I? It should be nums.length. If I is the start of the window and the window has length k, then the window occupies indices I through I plus k minus 1. What condition must I plus k minus 1 satisfy to still be a valid index in the array? Okay, must be not quite. Think carefully. If I is the start of the window, okay, and the window has length k, then the window occupies indices I through I plus k minus 1 plus k minus 1. Okay, what condition is time plus k minus 1 satisfied to still in trace of 4 and I is moved at 2, when I is moved at 1, I plus k becomes 2. When I is moved at 3, it is k minus 1, I plus k minus 1 must be less than num started it. Rather so must be less than. So exactly, so simplify that. What does your loop condition become in terms of I? So in terms of I, the loop condition becomes for I equal to 0, I for I equal to 0s. So this is the condition I plus k minus 1, I plus k minus 1 should be less than equal to null start. I think we can start I from 1 because the first sum we have already calculated. I equal to 1, I plus k minus 1 should be less than equal to nums dot length, then I plus this will be the loop condition for I. One thing to apply is I equal to y1. I is equal to 1 because we are already calculating the first sum starting from I equal to 0 and going up till I less than k. You have got a solid understanding of the approach. Let's recap what you have before coding. Initialize sum from index 0 to k minus 1. Set max sum equal to the initial sum. Loop from I equal to 1 while I plus k is less than equal to nums dot length. Each iteration subtract nums of I minus 1 and add nums of I plus k minus 1. Update max sum if larger, return max sum my k. Good. There we are, the approach finalized. Now let us go to LeetCode and complete our solution. So here we are in LeetCode. First, let us declare some variable to 0. Then initialize the first somewhere. It will be let chi is equal to 0 while I is less than k. Sum plus equal to nums of I. While I is less than k, sum plus equal to nums of I. Initialize sum from index 0 to k minus 1. I is 0, so in case of say, in case of this example, wherein we have 1, 2, 3, 4 elements and k is 2, what we are seeing, I will run from 0 to less than k, sum will be equal to nums of I, which is 0 and 1, which is true. So that will be the sum. Now that same, when we apply to k equal to 4, it becomes I will go from 0 to less than 4, which is 0, 1, 2, 3. And in this case, the sum will be 13 minus 13, 0. Set max sum equal to that initial sum. Now loop from I equal to 1 while I plus k is less than equal to nums dot length.
Correct. It starts with I equal to k, so maxSum equal to the initial sum.
So instead of some variable, we can directly use maxSum. Right? Why do you use two variables? Right? maxSum equal to 0. And then maxSum plus equal to nums of I. Then we are going to loop from I equal to 1 while I plus k is less than equal to nums dot length. Here we haven't incremented I, so we do I plus plus. So we have got our first sum. Then after that we initialize I equal to 0, and then we initialize I equal to 1. Then we say while I is equal to 1, I plus k is less than equal to nums dot length. Then we have to subtract nums of I minus 1 and add nums of I plus k plus 1. Update maxSum if larger. So we say maxSum is equal to math dot max of maxSum, comma, here maxSum minus nums of I minus 1 plus nums of I plus 1. So here what we are doing is, from the maxSum or the initial sum, we are subtracting nums of I minus 1 because this has been dropped, and then we are adding nums of I plus 1 because this has been added. And this will give us the maxSum. Once we have the maxSum, we return maxSum by k. Once this loop ends, so at last we return maxSum by k, which is the average that we need. However, here we have not incremented I, so below we will increment I plus plus. So this is our final code. First, we initialize the first sum value, or initialize the sum value for the first window. We are starting from I equal to 0. You will go up till I less than k, and you will add the value of maxSum. Let me just try run this code first. So here, going to VS Code. This is our code, and the nums array is equal to say 1, 2, 3, 4, and k is equal to 2. So for the first initially, this code will be executed, this while loop will be executed, and here we are going to initialize the value of maxSum. So I is equal to 0, k is equal to 2, while loop starts. Now 0 is less than k, hence maxSum is equal to maxSum plus nums of I, which is 0, which in turn becomes maxSum is 0 plus nums of 0 is 1. So for first iteration, maxSum is 1, or our initial sum is 1. After that, I is incremented, so I becomes 1, k is still at 2. Here again, maxSum is equal to maxSum plus nums of I is now 1. Maxsum from the previous iteration is 1 plus nums of 1 is 2. Hence, this is our initial maxSum. This is our initial maxa. After that, we are again initializing I equal to 1. I don't think there's a need because I is already 1. No, we have to. So we have initialized I equal to 1. Then we say I plus k, that is, then I plus k is 1 plus k is 2 should be less than equal to nums dot length, which is 4. Yes. So 3 is less than 4. The condition is true. Then inside that, what we are doing, we are initializing maxSum equal to math dot max of maxSum. The initial maxSum is 3. Then maxSum, which is 3, minus nums of I minus 1, which is 0, plus nums of I plus 1, which is 1. So here, this equation becomes math dot max of 3 comma 3 minus nums of 0 is 1 plus nums of 1 is 2. Hence, at last we have math dot max 3 comma 3 minus 1 is 2, 2 plus 2 is 4. Now the max of 3 comma 4 is 4. Hence, this is the new value for maxSum. And then we are incrementing I by 1. So I is now 2, and 2 plus 2 is less than or equal to 4, which is true. That is, 4 is less than equal to 4. Hence we come inside the while loop. Here maxSum is equal to math dot max of maxSum, which is currently 4, comma maxSum, which is 4, minus nums of I minus 1, which is nums of 1 since I is 2, plus nums of I plus 1 since I is 2, so nums of 3. So here what do we have? We have this becomes math dot max 4 comma 4 minus nums of 1 is 2 plus nums of 3 is 4. This becomes math dot max 4 comma 4 minus 2 is 2, 2 plus 4 is 6. So our new maxSum is 6. And at last, we return maxSum by k, which is equal to 6 by 2, which becomes 3, which is correct. 6 by 2, which is 3. So here I have reached to 2 plus I plus k, right? What was the terminating condition? The terminating condition is while I plus k. Yes, 2 plus 2. Now when I becomes 3, so 3 plus 2 becomes 5. Now 5 is not less than equal to 4. Hence, when I equals to 3, this while loop will not be executed. And our max average is 6 by 2, which is 3. Let us verify this. So here is the code, and guidance of the same using nums equals 1, 2, 3, 4 and k equals 2. A good effort on the dry run, but there's a bug. Look carefully at your sliding step inside the loop. maxSum minus nums of I minus 1 plus nums of I plus 1. You are subtracting nums of I minus 1 and adding nums of I plus 1. For a window starting at index I with size k, which element are you dropping and which element are you adding? Express both in terms of I and k. For a window starting at index I with size k, which element are you dropping? And which element are you adding? Okay, got it. The dropping of element is correct. However, the adding of element must be I is 1, 2. Must be I plus k minus 1. Yes. But there's still another bug hiding in your code. Look at this. maxSum is equal to math.max, maxSum, comma, maxSum minus nums of I minus 1 plus nums of I plus k minus 1. What is maxSum on the left side of this assignment? And what is maxSum inside the expression on the right side? Are they the same thing and is that correct? What is maxSum on the left side of this assignment? Okay, what is maxSum on the left side of this assignment? MaxSum on the left side will be the result of math.max. But think more carefully about the right side specifically. You are computing maxSum minus nums of I minus 1 plus nums of I plus k minus 1 to get the currentWindowSum. But what is maxSum at that point? Is it guaranteed to be the previous Windows sum or could it be something else? Okay. Initially maxSum I equal to 0 less than k. For first window maxSum is correct. And then for the second window, maxSum's value is say let's maxSum. Then maxSum minus I plus k minus 1. See what is missing over here? MaxSum is equal to math.max. What happens if a previous window had a larger sum? What value does maxSum hold then? If a previous window here is the tyrant part for maxSum. But you have just exposed the bug yourself without realizing it. Look at iteration I equal to 2. Math.max 4, comma 4 minus nums of 1 plus nums of 3. You are using maxSum equal to 4 to compute the new window sum, but 4 is not the sum of the previous window. It's the maxSum seen so far. They happen to be equal here, but that's a coincidence. What if the array was 1 to 1, 5, 2, 4 with k equal to 2? The window sums are 6, 7, 6. Trace through your code and see if maxSum inside the expression still gives you the correct current window sum at each step. Okay. 2, 5, 2, 4. 1, 5, to sur. Maxsum will be maxsum plus nums of 0, 1, then I is 1, k is 2, maxsum plus nums of 1, so 5. So this becomes our initial maxsum, and we are reinitializing I equal to 1. Then I plus k is less than equal to 4. Yes. 3 is less than 4. So math.max, initial maxsum is 6. And here we are using maxsum minus nums of 0 plus nums of 1. So 6 minus nums of 1, nums of 0 is 1 plus nums of 1 is 5. So this becomes 6 comma 5 plus 5, 10. So maximum is now 10. Okay. So in this case, how can maximum be 10? No, it should not be. Because if we are comparing the max of this is the calculation of our next window, and this is the calculation of our first window. So for first window 1 plus 5 is 6, but for the second window, that is 5 comma 2, it should be 7. So what we are doing is we are doing 6 minus nums of 0 is 1. Oh no, this should be different. This is nums of I minus 1, that is nums of I plus k minus 1. So when we do nums of I plus k, that is 1 plus 2 is 3, 3 minus 1 is 2. 6 nums of 0 is 1, and nums of 2 is 2. So this becomes 6, 5, 5 plus 2, 7. No, it is correct. 7. So max sum for the second window is 7, right? Now when I becomes 2, 2 plus 2 is less than 4, whole is less than equal to 4, correct? So here we have maximum 7, then 7 minus nums of I minus 1, nums of 1 is, nums of 1, it is correct, and this should be I plus k minus 1. So 2 plus 2 is 4, 4 minus 1 is 3, this is also correct. I plus k, I is 2, k is 2, 4, 4 minus 1 is 3. Then this becomes 7. Here we have 7 minus nums of 1. Shouldn't this be nums of 2? Right. So first this window was calculated, then this window 5 comma 2. Now we are calculating 2 comma 4, right? 7 minus I is 2. Maximum is equal to nums of I minus 1 plus nums of I plus k minus 1. So 2 minus 1 is 1, correct? Then 2 plus 2 is 4, 4 minus 1 is 3. This is also correct. So we have 0, 1, 2, 3. This is 3. Here nums of 3 is 4, nums of 0, 1 is 5. How can this be the window when k is 3? Something is wrong. I have tried on the board. The last max sum calculation, something is wrong. Something is wrong. That is max sum is come, that is math dot maxsum, math dot max of maxsum comma maxsum minus nums of I minus 1 plus nums of
I plus k minus 1 for I equal to 2 is considering I of 1 and I of 3, which is incorrect.
This should consider I of 2 with I of 3.
So here we have 7, 7 minus 2 is 5, 5 plus 4 is 9. The answer is 9. Which is incorrect.
Exactly. You have spotted it. At I equal to 2, you are subtracting nums of 1, which is 5. But the previous window was 2 comma 4 starting at index 1. So you should be subtracting nums of 1, which is correct. Wait, let me make this concrete. The window at I equal to 2 should be 2 comma 4 with sum 6. But your code computes 7 minus 2 plus 4, 9, which is wrong. The problem is clear now. You are doing max sum minus nums of I minus 1. But max sum is 7. Okay, 5 plus 2 is 7. The max so far, not the sum of the previous window, which was 7 by coincidence in iteration 1, but breaks here. You need a separate variable to track the current Windows sum. What should that variable be in, and how does it update each iteration independently of max sum? Current Windows sum, got it.
Max sum equal to current Windows sum. Update current Windows sum. So current Windows sum minus equal to 20. Sum is equal to current Windows sum minus this one.
Then max sum equal to math dot max sum, math dot max of max sum.
Current Windows sum. Let us do this now. So what we are saying, initially current Windows sum is
equal, and how does it update each iteration independently of max sum? That max sum equal to current Windows sum, update current Windows sum. So when I equals to 2, so current Windows sum becomes should be previous Windows sum, not current Windows sum.
Let me try run this one. So what we have, split right q, this is our code, and the columns array is 1, okay, this is 1524 k equal to 2. So initially previous window sum is equal to addition of 1 plus 5, which is 6. Then we have I equal to 1. So in that case, 1 plus 2 less than equal to 4, 3 is less than 4. So it becomes, here we initialize maxSum equal to previous window sum, that is maxSum equal to 6 previous window sum. Then we update previous window sum. So previous window sum is nothing but previous window sum, that is 6 minus nums of I minus num, which is nums of 0. So nums of 0 is 1 plus nums of I plus k minus 1. Nums of I is 1, k is 2, 3 minus 1 is 2. Nums of I plus k, that is nums of I minus 1, subtract 1 from the sum, good, and then add I plus k minus 1, add 2, which is 2. So subtract 1 and add 2. This is not previous window sum, this becomes current window sum. This is 6 minus 1, 5, 5 plus 2, 7. This is not previous window sum. This is the current window sum, that is 5 plus 2. So this gives the current window sum, max sum equal to the initial sum, right? And we have the previous window sum. Then we check math.max of max sum, which is set to 6. And here we have updated previous window sum. This is now 7. So it becomes max sum comma previous window sum, which is 6 comma 7. So now max sum is equal to 7. But this is getting overwritten when I is incremented, and we call max sum equal to previous window sum. So previous window sum is 7, right? So again we are reinitializing max sum. So max sum is reinitialized to 7, which is correct. And then we calculate, I think the naming convention is not good. Here we will use initial sum. Then initial sum is this. So what we will do, let us not assign anything to max sum as of now. Here we will calculate current window sum. So current window sum, we haven't declared it. Let us do that. Or let current window sum is equal to, is plus equal to current window sum plus equal to nums of I k minus 1 minus nums of I minus 1. Current window sum, then we use let max sum also we update max sum is equal to math dot maxsum of 0 comma current window sum. Okay, you can't declare and compound assign at the same time. More importantly, what is currentWindowSum initialized to before the loop, and what does it need to be for the first iteration at I equal to 1 to work correctly? What value should currentWindowSum hold before the sliding loop begins? Before the sliding loop begins, currentWindowSum should be equal to the initial sum. Then we do before the sliding loop begins, also you initialize maximum equal to 0 is starts here. What if all numbers in the array are negative? Can I initialize maximum equal to initial sum as well? Starts at the best sum you have seen so far. The first window and handles negative numbers correctly. Okay, so max sum will also be initial sum. So this is the final code. Let us run it once. Here is the final code. Array, but there's still a bug. Look at it is inside your loop. Current window sum equal to initial sum. You are resetting current window sum back to initial sum on every iteration. That means each window is being computed relative to the first window, not the previous window. Try this, try it. Fixed. Work. 1524 k equal to 2. K equal to 2. So what do we have? I equal to 0. Okay. Initial sum will be 6. Initial sum is 6. Now initial sum is assigned to max sum. So max sum is also 6. And current window sum is mix of 6. Now when I is equal to 1, so current window sum is equal to nums of I plus k minus 1. That is 2 minus 1 is 1, 5 minus nums of I minus 1, which is 5 minus 1 is 4. So current window sum plus equal to 4. So current window sum is 6. ये वापस गलत हो गया यार ये. Current window sum is equal to 6. Now when we update current window sum, to 6 plus nums of I plus k minus 1, nums of I is 1, so I plus 2, 3 minus 1 is 2, 0, 1, 2, right, 2 minus nums of I minus 1, I minus 1 is 1. Which is 1. So it becomes 6 plus 1, 7. Okay, currentWindowSum is correct. Then maxSum is equal to math.max of maxSum is equal to math.max of maxSum. maxSum is 6, comma, and currentWindowSum is 7. Is 7. So maxSum is 7. Then I is equal to 2. In that case, currentWindowSum is equal to currentWindowSum, which is 7, plus I plus k minus 1, suppose plus 2 is 4, 4 minus 1 is 3, which is this 3, which is 4 minus the nums of I minus 1. So I is 2, I minus 1 is what? Subtract 5 minus 5. So it becomes 7 plus 4 minus 5 is minus 1. So it becomes 7 minus 1, which is equal to 6. Now maxSum is equal to, maxSum is already math.max of 7 comma 6. So it will return 7 and their answer will be maxSum by 2, which is 3.5. Think about nums of 5, k equal to 1. The sliding loop never runs. Does your code still return the right answer? Trace through it. Nums of 5, k equal to 1. So I equal to 0, I is little in the initial sum plus equal to nums of I, which is 5. Now I is 1. So maxSum is initial sum, currentWindowSum is initial sum, I plus k, so 1 plus 2 is less than equal to, y will never execute. Yes. Edge case handled by the current code. Complexity big of and time big of on space. Code readability, you have 2 while loops where a for loop would be cleaner and more idiomatic. For index based operation, the intent would be clear. Naming initial sum is misspelled, should be the k. Unnecessary logic, none. Clean interview communication, you correctly identified. Let me just rename this. Oh, I am initial sum. Done. Now we will copy paste this into LeetCode. So going to LeetCode, should remove this, paste, save, run. Okay, so all cases are running. Let me submit this. Fantastic. The runtime is 1 millisecond. Great. So we have successfully solved the maximum average sum array problem, wherein the DSA concept that was used was that of sliding window. Initially, first we calculate the initial sum for the first window. So this is where that calculation happens. And secondly, what we do, let me outdate the comments. Initial sum, currentWindowSum is initial sum, then update currentWindowSum and then max. Then calculate or check which is a max among maxSum and currentWindowSum, and at last return maxSum divided by k. So that is updated. Now let us go to Claude and see what is the score. Okay, score is 7.5 out of 10. One concrete improvement for next time: before writing a single line of code, explicitly state your edge cases out loud
empty array k equal to nums dot length, all negatives. It shows maturity and prevents bugs like the maxsum equal to 0 initialization issue, which I had to prompt you on. After this, at last we have our 5-minute post-mortem. Let's do that. Ready for the post-mortem? Yes. What clues did you miss? The problem says any answer with a calculation error less than 10 raised to minus 5 will be accepted. That's a direct hint that you are returning a float. You never explicitly acknowledge that. In an interview, calling that out shows you read carefully. Also, the constraint that k is always valid, that is k is greater than or equal to 1 and less than or equal to n, means you didn't need to guard against invalid k. But you never stated that assumption out loud. Interviewers notice when you read constraints versus ignore them. What pattern should you have recognized faster? Fixed window size plus contiguous array equal to fixed sliding window. You did get there, but you initially described tracking both left and right pointers separately. The cleaner mental model for fixed window is just a single index I representing the window start. Variable size windows need 2 pointers. Fixed size only needs 1. What would an interviewer think? Positives, you reasoned well, caught bugs yourself during dry runs, and understood the optimization without being told. Concern, the maxsum equal to 0, initialization bug needed prompting. An interviewer would expect you to proactively think about negative numbers. That's a standard gotcha, and missing it unprompted costs input. What would you do differently next time? Before coding, say this out loud. Let me think about edge cases. All negatives, k equals array length, single element array. One sentence, it reframes your initialization decisions immediately and prevents the class of bugs you ate today. And by this way, we have successfully solved the maximum average subarray problem, which we are using initial sum, calculate initial sum, then assign initial sum to max sum, assign initial sum to the current window sum. Then our terminating condition is I plus k must be less than or equal to nums dot length. When that is true, what you do? You calculate the current window sum and check if the current window sum is greater than the existing max sum. If yes, assign max sum equal to current window sum, and at last return max sum divided by 4. In this way, we have successfully solved this problem. So if you have learned something valuable today, please do like, share and subscribe. Thank you.